Cool. All right, while you guys are working on that, I passed this out, and I also passed this piece of paper out as well. So just so you guys are aware, this is the template you will be assessed on for redox. You'll obviously be doing different chemical reactions and then writing them up. Right now we are doing them as a practical, but on the actual assessment, I'll give you just the description to help save us some time. I will set this up like I did ion identification, where I'll give you guys 2 chances and I'll give you guys the better of the 2 grades. You only have to show me once that you know how to do this, which is really good. I've also designed it to be quite kind to you guys. So I'll explain as I'm working what sort of things we need to do. In fact, we will actually cover a good chunk of what you have to do for this internal today. So that's some good news. There is some extension work that I will give if you guys want to give it a go, but you don't need to have to do it for the external. Or sorry, for the, not external, for the internal. However, that being said, if you're trying to get top scholar in level 2 chemistry, I would expect you to learn this additional extension stuff, okay? But the guidelines of the assessment say you don't actually have to do it, so that's why I'm not doing it. Save us some time. Okay, so the first thing we are thinking about is what are we observing for the chemical reaction we just set up. So just to kind of give you an idea of what we did, we had taken iron in a nail, solid form. Fe in the solid form, and we added it to a solution of copper sulfate. All right, I'm just writing down what we've done so we know experimentally what we did. As you guys can see, probably already, you could see that a chemical reaction was already starting. Some of you guys noticed that the nail was starting to turn a blackish color. I'll talk about what's happening and why when we do observations, but we'll just start with this sort of bit here and some of the equation stuff. So first thing to do when you're thinking about this assessment for the achieved is writing down the definitions of oxidation and reduction. I'm hoping you guys got that from the pre-learning. So redox is a specific type of reaction with the transfer of electrons. Remember that electrons cannot be created or destroyed, so it's really important that they're transferred from one to another. So it comes from one half of the reaction and it goes to the other half of the reaction. So for the oxidation, this is going to be loss of electrons. And then those electrons, because they don't get destroyed, go somewhere else. They're going to the reduction half of the reaction, and so the reduction is the gain of electrons. So first thing I need you guys to do for definitions, define oxidation. Oxidation is the loss of electrons, whereas reduction is the gain of electrons. So something for you guys to memorize. There's some acronyms to help you guys remember that. The first one is oil rig. So oil, rig. So oxidation is loss, reduction is gain. The other one you can use is Leo, the line says GER. So loss electrons oxidation, gain electrons reduction. I would suggest at the start of the assessment that you write down one of these 2 acronyms so that way you make sure you get this the right way around. Are you okay with that so far? All right, cool. So next thing we got to think about is what's happening with this chemical reaction. So we have iron, we have copper, and we have sulfate. So next thing I would suggest you do is look at some of these sheets here. This gives you a list of all the different types of reactions. They are not in any sort of oxidation or reduction order. Same thing with this side, it gives you all the colors. Something to keep in mind is this is the resource sheet, so you will be getting this on the assessment, so you don't have to memorize any of this. So what I want to look for when I'm looking for this is I want to look for things like copper, because I want to see what's happening with that. So we have copper metal, which is pink. I would also say it's a brownish color. You have copper, the ion, which is blue. The other thing we're looking for is my sulfates. So that sulfate is a colorless ion. And then we're also looking for the iron. So we have iron metal, which is gray. We have the iron 2 ion, which is a pale green. And then we have iron 3, which is a pale orange. So these are to help us figure out what's going on in that chemical reaction. First thing we can start to notice when we're looking at this, and in fact, I might start looking at observations because that's going to help you figure out what's going on, is we need to figure out the reactant and the product and the reactant and the product, and we need to figure out who's oxidation, who's reduction. There are technically 3 things in this reaction, so we need to figure out which of the 2 is actually part of the reaction. Now, since I've added copper to copper sulfate, I can already assume that, that the iron is going to be involved, because that's only one thing and that's 2 things. Does that make sense, or should I backtrack? I think we need to backtrack. Okay, so I have added iron and I've added copper sulfate. I know if I just had copper sulfate on its own, it wouldn't do any reaction. So I know that I must have been a reason that I've added the iron. So I know iron must be involved in this reaction. The next question is copper or the sulfate involved in the reaction? Okay, so looking at what we have, we can go backtrack. So I know I'm dealing with iron, the metal, because I could see that it was a gray metal. It was the nail. So I know I have that guy right, where'd you go? Here? Agree? Let's go look on the equation sheet and see if I can find the iron as a metal. So I have iron 2 and I have iron here. I have 2 iron ions here and basically nowhere else that I see it. So if I wanted to grab the iron metal, I'd be grabbing these 2. Because that one has the metal. So already I can start concluding what's happening in my beaker. Iron, the metal, must be converted to iron 2, the ion. And when we look at it tomorrow, we will hopefully see that iron 2, which is a greenish color. So I'm hoping by tomorrow that blue color solution is going to change to a green, potentially an orange, because it could do the second oxidation step. Are you okay with how I've gotten that? All right. So when I'm looking at this guy here, I'm starting with iron and I'm going to iron 2. Are we all right with that one? Okay. I need to now figure out, does this go in the oxidation half or the reduction half? So I need to think about, if I have iron and it's now going to a positive ion, did I gain or lose electrons? Remember, electrons are negative. So I've lost it. So if I think loss of electrons, that is my oxidation. So I would have Fe as a solid going to Fe2+, which is aqueous in solution. So the thing to keep in mind is that the nail is going to lose mass, but it's not dissolving. All right, the nail's not dissolving, it is reacting to form iron 2. And when it does that reaction, it's going to lose the metal component that's a solid. Are we okay with that so far? Right, we'll hold off on this one because we're going to wait till tomorrow to see some more of the observations. So that way we can be sure, is it the copper or is it the sulfate that it's reacting? Let's start talking about some of the other requirements so you guys can get ready for it. I thought I was going to get up to the excellence today, but in reality, because I haven't given you the second half of the reaction, we're only going to go up to the merit. So achieve bit is figuring out what is going to what, and then give me that definition. Same thing, what is going to what, give me the definition. Then you're done. 3 credits in the bag. Merit, you need to talk about observations, which we'll do tomorrow. You also need to talk about the specific number of electrons lost or gained, and we have to give half equations. So if I wanted to start with my oxidation half equation, we have Fe, the solid, becoming Fe2+, which is aqueous. Now, what I need to add are my electrons to then communicate, are we gaining or losing electrons? So in this case, I have no charge, and in this case, I have a positive 2 charge. Remember that electrons are negatively charged, so I have lost 2 electrons, and that's how I would indicate that in the equation. So for oxidation, you should see the electrons on the product side, because it's lost it. It's a nice little hint. On this side, the reduction half, you should see the electrons on the reactant side, because you're gaining it. So you should have the electrons on opposite sides of the equation. That's a good way to double check and idiot check yourself. If your electrons are on the same side, you've done something wrong. All right? So that's all I'm going to get up to for today, because I'm very mindful that we need to have more information before we can move on here. Okay? But that's the beginning of our assessment and what it's going to look like. Cool.